What is artificial intelligence all about? Artificial intelligence, AI, refers to the simulation of human intelligence processes by machines, particularly computer systems. The goal of AI is to enable machines to perform tasks that would typically require human intelligence, such as reasoning, problem solving, learning, understanding natural language, perception, and decision making. AI technologies aim to mimic human cognitive abilities and automate complex processes to enhance efficiency and accuracy in various domains. AI encompasses a wide range of techniques and approaches, including machine learning. This is a subset of AI that involves training algorithms to learn patterns from data and make predictions or decisions based on that learning. It includes techniques like supervised learning, unsupervised learning, and reinforcement learning. Neural networks and deep learning. These are specialized machine learning algorithms inspired by the structure and function of the human brain. Deep learning involves using neural networks with multiple layers to learn hierarchical representations of data. Natural language processing, NLP. NLP focuses on enabling computers to understand, interpret, and generate human language. It's used in applications like language translation, sentiment analysis, and chatbots. Computer vision. This area of AI enables machines to interpret and understand visual information from the world, like images and videos. Computer vision has applications in facial recognition, object detection, and medical image analysis. Robotics. AI is used to create intelligent robots that can perform tasks in the physical world, such as assembly line work, exploration of hazardous environments, and even social interactions. Expert systems. These are AI systems that emulate the decision-making abilities of a human expert in a specific domain. They are used in fields like medicine and finance for diagnosis and decision support. Autonomous systems. AI plays a crucial role in developing self-driving cars, drones, and other autonomous vehicles that can navigate and make decisions without human intervention. Cognitive computing. This involves creating systems that can simulate human thought processes, enabling them to understand, reason, and learn from information in a more human-like manner. AI ethics and bias. As AI systems become more sophisticated and integrated into society, concerns about ethics, bias, transparency, and accountability have gained prominence. Ensuring that AI technologies are developed and used responsibly is an important aspect of the field. AI has made significant advancements in recent years, with applications ranging from virtual assistants like Siri and Google Assistant to recommendation systems on streaming platforms, medical diagnosis, and even playing complex games like Go and poker at a superhuman level. The field of AI continues to evolve, pushing the boundaries of what machines can achieve and sparking discussions about its societal impacts. What is machine learning all about? Machine learning, milliliter, is a subset of artificial intelligence, AI, that focuses on developing algorithms and models that enable computers to learn from data and make predictions or decisions without being explicitly programmed for each specific task. Instead of relying on explicit instructions, machine learning systems learn patterns and relationships from large datasets, allowing them to generalize and make informed decisions on new, unseen data. The core idea behind machine learning is to enable computers to improve their performance on a given task through experience. This is achieved by using various techniques and algorithms that allow the system to adjust its parameters based on the input data and the desired output. Here are some key concepts within machine learning. Training data. Machine learning algorithms require a dataset known as training data to learn from. This dataset consists of input examples along with their corresponding correct outputs or labels. The algorithm learns patterns and relationships in the data to make predictions. Features. Features are the characteristics or attributes of the data that the algorithm uses to make predictions. Properly chosen and engineered features play a crucial role in the performance of machine learning models. Supervised learning. In supervised learning, the algorithm is trained on labeled data, meaning the training dataset includes input-output pairs. The algorithm learns to map inputs to outputs and can then predict outputs for new, unseen inputs. Unsupervised learning. Unsupervised learning involves working with unlabeled data. The algorithm identifies patterns or structures within the data without being provided explicit output labels. Semi-supervised learning. This approach combines elements of both supervised and unsupervised learning, where a model is trained on a combination of labeled and unlabeled data. Reinforcement learning. Reinforcement learning is about training agents to make sequences of decisions to maximize rewards. Agents learn by interacting with an environment and receiving feedback in the form of rewards or penalties. Neural networks and deep learning. Neural networks are a class of algorithms inspired by the structure of the human brain. Deep learning involves using neural networks with many layers to extract hierarchical representations from data, enabling them to learn complex patterns. Feature extraction and transformation. Preprocessing and transforming the data into a suitable format is often crucial for successful machine learning. Techniques like normalization, scaling, and dimensionality reduction help improve model performance. Model evaluation. After training a machine learning model, it's important to evaluate its performance using metrics relevant to the specific task, such as accuracy, precision, recall, F1 score, etc. Overfitting and underfitting. Overfitting occurs when a model learns noise from the training data and performs well on it but poorly on new data. Underfitting happens when a model is too simple to capture the underlying patterns in the data. Hyperparameter tuning. Machine learning models often have hyperparameters that need to be set before training. Hyperparameter tuning involves finding the best combination of hyperparameters to optimize model performance. Machine learning has found applications in various fields, including image and speech recognition, natural language processing, recommendation systems, autonomous vehicles, financial modeling, and healthcare diagnostics, among many others. As datasets and computing power continue to grow, machine learning techniques continue to advance, enabling more accurate and sophisticated predictions and decision-making. Thanks for watching this video. If you liked the content of this video, like the video, share it with your friends, near and dear ones. Do let me know your comments and subscribe to my channel at Tekprofessionaltv.